So this tutorial is going to be run by this main workshop.m script, and you hopefully have all had a chance to download the files from GitHub that make up this VGC Argo Mat toolbox that was put together by Hartmut Frenzel and Jonathan Sharp, with contributions from Andrea, Josh Plant, Tanya Yui, Rue, and myself. But really, I want to give a huge shout out to Hartmut and John for putting together this toolbox, because it's really got a lot of functionality and it's very well put together, and they did a great job. So let me get the right directory. Okay, so here we are. I'm in the BGC Argo Map toolbox. I've got the main workshop.m script pulled up, and we're going to run through this. And I'm going to step through it using the run in advance functionality in Matlab. Okay. And well, there's sort of 3 different main exercises, and I'll kind of go through each one and then pause for questions sort of at the end of each one. So first is just a little bit of housekeeping to close up any available figures or clear the command window, all that stuff. Okay, so the first thing we're going to do, actually, before we really look at any data, is to initialize our settings, and as well as the location for where we're going to download our SPROF index file, as well as the profile files that we're going to download from the GDAC. So this is all done in this one nice script, which is initialize Argo. And so that has a lot built into it. I'm not going to be able to kind of go through all the different details, but there's a lot of settings in here. If you want to change any of the settings for the toolbox, you can dig in here. It's commented pretty well, so it should be easy to figure out what you're trying, what you need to change if you do. But hopefully, if you just go ahead and if I run in advance this, the initialize Argo, what it did was it created an index folder in my current path. So wherever I've downloaded the BGC Argo Mat toolbox, it creates an index folder that downloads the SPROF index file. You can see this is the Argo Synthetic Profile Index. And what does that look like? Well, if we open it up, it's a text file, and it's a very large file that has a few lines of headers, but then essentially it gives you a lot of information about each individual netcdf file, profile file that's on the GDAC. And the initialize Argo function of this toolbox reads in that data and puts the information into a few different structures. So Matlab structures, these are the global, these are global structures, the SPROF, float, and settings. And we can look a little bit at what those are by running this block of code. So this is spits out a few things. So first of all, I just want to point out that there's these 3 different structures that have information about the SPROF, or information from the SPROF index file, and also from on a per float basis, as well as different settings that are used in the toolbox. Okay, and then turn that up real quick. Okay, so then if we want to, as just an example, we want to look at the profile ID numbers and available sensors for one of our new GO-BGC floats that was just deployed fairly recently. So this is float number 5906439. So if I tell it to find all the floats where the WMO ID is equal to this, then that gives me an index in the float structure of the floats where the data that belongs to this float, and then we can query it to find the indices of the profiles that belong to that float within the SPROF file, as well as the dates of those profiles, and then what sensors were on that float. So this can be really helpful if you want to just quickly figure out what's on a float. Okay, so with that, we're going to next move along to the first exercise. And in this, we're going to download, we're just going to look at a single float. So this is if we, we know the WMO ID here, 5904859, which is a SOCOM BGC float. And we're going to download the trajectory, or we're going to, plot the trajectories and the profiles and show kind of some examples of, or in this example, you'll see what the difference between the unadjusted and adjusted data, as well as what happens when you apply the QC flags. Okay, so the first thing is we're just going to set our WMO variable equal to our WMO ID and download the float. So this download float is one of the scripts that's contained in the auxiliary folder up here. So run and advance. And as you can see, it's attempting to download from the US GDAC this the sprof.nc, so the netcdf sprof file associated with this float. And it successfully did that. And you can see over here in my profile folder that there's now this sprof file. And we can see, well, what is in this file by looking just at NC-DISP. This is one of the built-in netcdf handling routines. I don't know if you're not familiar with netcdf routines in Matlab. This is a really handy one. And so if we run that block of code, it just spits out all the different variables you can see here that were contained in that float, or in that file. And there's your typical netcdf format where you have different dimensions as well as a data type and different attributes. And you can learn a lot about all the different variables by just looking at what is output by NC-DISP. Another command that you can use to extract all that data from the netcdf file is this nc-info, and it takes all the information in in any netcdf file and puts it into a structure. So if I run this, we'll see now we have a new structure called S, and in that S you have tells you the file name that it was created from, as well as the dimensions. You have all the variables, and each of the variables you can see has different size, data type, so on and so forth. There's a lot of different things in the file, and this can be a way to as I just output to the workspace the variable names. So this would be like, if you don't know what are the names of the variables, you need to kind of know something about what the variables are called in order to interact with the file. So this would be a sort of a first thing to do is to read out the variable names so that you can call them later. Okay, so that's what we're doing there. Now, next we see that nitrate is available, so that's great. This float has nitrate, and there's several different, there's the adjusted, there's the QC flag, there's the error associated with it. So each parameter has several different variables. So what we're going to do here next is call this load float data, and that is one of the functions or one of the scripts in this toolbox, which lets you select by a specific WMO number, and it takes the data that we're going to use and puts it into two different structs. The main one is the data, and then the metadata. And we're going to tell it that we want to just take out salinity, temperature, and nitrate. So if we do that, now you'll see we get a data structure that just has sort of a smaller subset of all the different variables that are in the netcdf file. And these are ones that, that we've told it. We have pressure, of course, but we just took out P-sal and temperature and nitrate. So those are the ones we told it to extract.
Alice?
Yes.
Question. I hear myself. I don't know. I see that there is different nitrate variables. One that said nitrate QC, nitrate depress, adjusted. Are we gonna talk a little bit about those type of like which variable we wanna use?
Yeah. So in the next few sections, I'll plot what the different ones are, and so you can see what they are.
Okay, good. Thanks.
But, I mean, it's a very good question. So right, especially for the BGC variables, it's really important to kind of know whether or not you're using the adjusted data or not. So each one of your variables will have, the raw data, which would just be the variable name. So nitrate or temperature or P-self or salinity, practical salinity. Then there's also a QC variable associated with that. That's a flag. It's a QC flag corresponding to the raw data. Then we have a adjusted parameter. That's the one that you want to use for the BGC data, and I'll kind of go through, show you why. And then the QC flag that applies to the adjusted data, which could be different than the QC flag that applies to the raw data. Hopefully that makes sense. There's also an estimated error associated with the adjusted data. We're not going to really use that in this tutorial, but it's there for you to look at. And then the depress is something that comes from the SPROF files and the way these synthetic profiles are created. I don't think you really probably need to use that. We're not going to talk about that in the tutorial, but it's just it shows you how much from the raw, how much of a pressure change there was between the raw data and the synthetic merged data. Happy to talk more about that offline if there's further questions. Okay, so next we're going to show that where are the profile locations from this float that we've downloaded. And that's this nice command called show trajectories. So there's three different ways in the toolbox, three different main scripts that plot the data. There's show profiles, show sections, and show trajectories. And so first we'll look at show trajectories, and it, as the name implies, it shows the trajectories from this float. And if okay, so you know what? There we go. So you can see that this float is in the high latitude Southern Ocean, around 70 degrees south. Here's Antarctica. This command just makes a nice plot of the float locations and for this particular float ID. And you can see one thing to note here is these straight lines, which some of you probably know what that is, but this float was under ice. And when the float's under ice, it doesn't get a position fix from a satellite when it profiles. And so even though the float's still profiling and collecting data, but it doesn't really know where exactly it was. So we interpolate the under ice data. So that's why you see these sort of straight lines. Okay, so now we can start to look at the salinity and nitrate from this data, or from this float. And we're going to do that in this next block of code. And we're going to plot profile plots for salinity and nitrate. And we're going to do three different instances. So the first command here, or the first time we call show profiles, we're going to tell it, number one, that this is a float ID that we're giving it instead of a profile or a list of the profiles. So that type floats tells you if you're giving it a float or you're giving a profile ID. And then this flag obs on will tell it to plot the individual data points. And then the first instance, we're going to plot the raw data. So this will be the unadjusted, just nitrate variable. And then the second time, we're going to plot the adjusted data. That's the default for this script. So you don't need to tell it anything special. If you don't tell it to plot the raw data, it will plot the adjusted data. And then the last time we'll look at what happens when we apply only QC flags of 1 and 2 to the adjusted data. Okay, so if I run that section, it'll pop up with 6 different figures, and it does give you some warnings. So these are fine. These are just telling you that basically some profiles have no valid observation. So like that profile is empty once you applied the QC flags. So we'll look at what's happening here. So the first plot that what we made was the salinity and raw values, and you can see, okay, there's pressure at the surface, saltier at depth. It looks pretty good, but there's a little, maybe an outlier here where if we look at the the salinity. Okay. So then if we look at the next plot that was produced, so this would be the salinity raw values. If we look at salinity, the next one that was produced was just the adjusted values. You can see that for salinity, it did take away some of those outliers, but not a big change. And then again, if we just apply the QC flags, well, the salinity data was pretty good to begin with. So there wasn't a lot of change there. But now if we look at nitrate, we'll see a much bigger change. So the first plot of nitrate is just the raw data. And you can see there is a lot of drift in this sensor. It's all over the place. This is not looking like good data, right? So, the nitrate.
Sorry.
Yes, this is not the, this is an early SOCOM float, and the nitrate sensor was not at its best. But we luckily can still use some of the data because we can, if we look at the adjusted data, so here is the second one of those plots where we're just looking at the adjusted data, and you can see that the adjustments really kind of take away the worst of the outliers, like out here with the 60 micromoles per kilogram of nitrate. And the data is sort of starting to kind of come closer together. You still see some maybe drift here. So then, and I should point out that in all these plots, that the black lines are all the profiles, and you can see how, because we selected obs on, the plot dots for the actual measurement, where the measurements were collected, and then the red line is the mean from the profiles that are shown. Okay, and so nitrate, this is just nitrate, all the adjusted data with any QC flag. Now what happens if we look at finally the nitrate data where adjusted data where the QC is good or probably good, so that's 1 or 2, and you can see now this looks much more like what we expect, and this looks like good data and something we could actually start to analyze. Okay, so then last in this example, we're going to plot the sections, the section plots for nitrate, again from this float, and this script shows sections.m. Also has a lot of functionality, and you can look at the optional inputs here, or by typing help show sections. And you can, some of the things that you can select are plotting the mix layer depth and how to plot the mix layer depth, or how to calculate the mix layer depth. Do you want to use a temperature criterion, which you flag 1, or a density criterion, which you flag 2? You can also plot isopycnals. It's a really nice function, and it uses a P color to make a plot. So we'll see, I'll go ahead and run that, and it will take a minute to make 3 different section plots. So again, the same sort of ones that we saw before. The first one, we're going to use the raw data, and we're going to use a temperature criteria for the, oops. So this is the section for the raw data and temperature criteria to calculate the mixed layer depth, which here in the high latitude Southern Ocean under ice, that temperature criteria doesn't really quite work so very well. So you can see this dark black line that was the mixed layer depth. this is sort of undetermined for most of the time. And you also see this, what we saw before, where there was a lot of bad data, basically, in the unadjusted or raw profiles. And then if we look now at the adjusted data, we can see that, we've kind of removed the most offending data, and things are looking better. And also, you'll note here, I've used a density criterion to calculate the mixed layer depth. So that works much better in the Southern Ocean, high latitude Southern Ocean, as expected. And then we also have some data that dropped out, where it's just that data was not adjustable, was not able to be adjusted. And then the last but not least is where we just have QC 1 and 2, the good data. Again, I'm using the temperature criteria to plot the mixed layer depth. But you can see now here, you start to see a real, real signal of what's going on in the ocean, where you have nitrate being drawn down in the surface layer in the summer and the spring when the ice is melted back, and then slowly building up over the winter as the mixed layer deepens, and so on and so forth. Okay, so that's the end of our first example. So I'll pause here to see if there's any questions, comments, anything.
Hi, Allison. This is. I have a little bit of feedback here.
It sounds good to me.
Oh, okay, good. So this is Tanya. Great job. Thank you for running through all this and for the examples. I just had a couple of comments as we were going through. The first being, I just wanted to make the point. So the SPROF index file, as you showed, is really going to be valuable to users. There's one thing that's not included in those files as you're exploring what floats you want to use and sorting by floats, and that's the project or program type. And I think most often, users will want to sort by geographic region or parameter and just get all the data that they can in that way. But if you are, for some reason, interested in looking at just SOCOM floats or just GO-BGC, you'll have to explore some of the other resources for categorizing floats that way. So I just wanted to mention that. And then just this exercise you went through, showing why you want the adjusted and QC flag of 1. I just wanted to emphasize again, it's really important, because Argo, some users may be wondering, well, why is this data even in the system, but one of the pillars of Argo is really to maintain all data in its raw form. So if you're not sorting by looking for adjusted fields or QC flag of 1, you really will run into issues no matter which float you're trying to access. So just wanted to emphasize that again. The adjusted data and QC flag of 1 is the raw. All the raw data is kept. So thanks.
Yeah, thanks, Tanya. Those are thanks very much for those comments. I appreciate that. Okay. Hopefully people are having success at running the tutorial script themselves. I'm gonna go ahead and clean up the workspace after that first exercise, and then so that's just closing out the.
Hey, Allison.
Yeah.
Before we move on, sorry, this is Yui. If anyone is having issues, just want to reiterate. You can type in your problems in the Slack, either the tutorial Matlab or there's a help desk Matlab channel, and there are people monitoring that. So if you have questions or issues, don't be shy and please tell us. We're here to help.
Yeah, absolutely, and we really, we hope that as much as you're able to, you can kind of follow along and be running this as we're discussing it, so that if you do have questions or problems, we have people standing by to help you figure it out. So we want to be able to you to leave with like some working code that you can use to start looking at flow data. Okay. The next exercise I think is really helpful for a lot of people, because maybe you don't really know which floats you want, or if there are any floats in your region, but you have a specific area that you're interested in, and so you want to, this toolbox has the capability where you can set a latitude limit, longitude limit, so like a box, a geographic box, and then as well as time bounds, and then select floats or profiles that fall within those bounds. And so we're going to show that an example of that here, looking at floats around Ocean Station Papa in the Northeast Pacific.
Allison?
Yeah.
Before you go, keep going, can I ask you something about the last question, part, the first part? We were looking at the all profiles from that float, not by a latitude or longitude. It took everything.
That's
right? Okay. I was just to make sure that. So yeah, how do you know that is like really like bad data and not like real data, that it was just taken in one point and then it went to another point and it was different?
Yeah, so I mean, for that particular sensor, we know from comparing with reference data, shipboard data, and things like that, that just doesn't, like those levels are way outside the bounds of what's actually found in that region of the ocean. But the point really is not that you need to know that that's bad data. It's that the data processors have looked at it and determined that it's bad. And so if you use the adjusted data, you don't have to worry about it.
Okay, good. I was just want to make sure.
Yeah.
Thanks.
No, thanks for that question.
Sorry, I want to add one thing to that. That the data adjustments, we do our best and to try to provide the best quality data possible for the community. But there's a lot of floats and there's a lot of data, and then so I really encourage everyone to take the mantra of trust but verify. And then so if something doesn't look right, look into it, and then think about it, and maybe, then you can try to correlate with other parameters like oxygen nitrate, for example, could very, very strongly. So, and then, but if you find data that you think should be flagged wrong, but it isn't, please contact us. Like we are, the more eyes on the better, the more people look at it, the overall quality goes up. So yeah, trust but verify.
Absolutely, and that's a really good point. And I didn't really kind of maybe highlight or emphasize as much as I should that there is also a difference between delayed mode and real-time adjusted data, and the adjustments are a sort of living data set. The adjusted data is, and so it can change too if an operator, if a float goes through a delayed mode review, which only happens every so many months. Then they can make adjustments to the different parameters that go into that adjustment. And so I guess my point being that if the profile is marked as a delayed mode profile, I think it's, somebody's reviewed it and said that it was good. There are real-time adjustments where we just carry forward those adjustments in time, and those could are sort of a little bit more subject to change. So especially if you're using the latest data, then you want to kind of be aware of these nuances. And there was, I think, a question in the chat about if there's a timestamp for when the latest adjustment was made. I'm sure that there is. I don't know exactly where it is in the netcdf files. Tanya might be able to tell us. I know in the MBARI maintains for each float QC history, but maybe Tanya.
It's in the last column of the Argo synthetic profile index.txt.
Great.
If you just look straight into the text file.
Yeah. Okay. Perfect. Even easier. Okay. Great. Okay. So hopefully everybody can still see my Matlab screen. And I think, where was I? Okay, yes, so we're going to do our exercise 2, and we're going to select some data from a particular geographic and time window. So the first block here is just setting up what those latitude, longitude bounds and time bounds are. So we're going to pick a 10-year window, or I guess 11 years, from 2008 to 2018. And so first we just input what those are. And now we're going to select the profiles with this nice command called select profiles. And so you can look more here in the header and see all the different information about how it's set up. But the main point is that you can select, you can specify to look for floats only with particular sensors. So if you want a float, we're gonna look here for only floats that have nitrate sensors. You can also, by using this outside argument, you can specify if you want to take, let's say you have a box. Well, maybe a float drifts through that box and it has profiles, outside of the box and inside the box. You can kind of select whether to include all of the profiles from all floats that ever pass through that box, or sort of, just retain the profiles in the space limits or the time limits, or both. So I'll show two examples of this, but in this case, we're going to select only all of the floats and all of the profiles that ever went through our box. And if I run this, you can maybe see. Well, first of all, it gives us, it spits out the number of matching profiles, which is 1,810, and these come from 7 different floats. And so now we can use show trajectories and tell it to use multiple colors for each float. So we're going to now give it a list of floats, and it's going to plot all the trajectories, and each float will have a different color. So if we run that, first of all, it's because it checks and it determines, oh, I don't have these sprof.cdf files. So first thing it does is download all of them, and you can see it populating over here into my profiles folder. And then the window, the figure that popped up over here shows all of the different floats that kind of passed through this box. And here we are. Here's Alaska and Canada over here, and this is near Ocean Station Papa. And we see 7 different floats that were in this region. And if we now want to look at some of the profiles from maybe one of these floats, we can use, again, show profiles, and we can tell it, let's say we want to plot salinity and oxygen, and we want to plot all the floats, or all the profiles from the first of these floats, and we'll do 2 different instances. The first is the plots that we saw before, where we will plot all the profiles and then we plot the mean of the profiles in red. And then the second case shows a different functionality of this show profiles script, which lets you just plot the mean and standard deviation. So that's using this argument method, telling it to use mean. Okay, so if I do that, we'll see 4 different plots pop up. The first is the salinity, and again, I didn't tell it to use the raw data, so it by default uses the adjusted data, which is what we want. And you can see, here's the fresh, what the salinity looks like near Ocean Station Papa and the top 1,000 decibars. If we then look at the mean and standard deviation instances of these plots, they show you a nice window. And then if we look at oxygen, you can also see similar kinds of plots for oxygen, and mean and standard deviation. Okay, any questions so far? The next example, let me clean up that first, but then the last example here is also using the select profiles function to pick the profiles within a given window. We're going to, instead of including all profiles from all floats that ever passed through this box, we're now only going to choose the profiles that are within the limits of our box in space and time. So that's done by choosing outside none. So now we're going to, as I said, look near Hawaii. So we're just setting up different latitude and longitude bounds, as well as a 3-year time window. And then this next command here, or block of code, that the select profiles command now gives us a list of the profile indices. So that's within the sprof index file, which lines correspond to the profiles of interest, and then also a list of the float IDs, the WMO IDs that correspond to those floats. So we have 5 floats and 252 profiles that match this criteria. And then in the next block, we will show the trajectories for the matching floats. So this is going to show the trajectories from the floats. So this will show all the profiles, not just the ones in our window. So again, it's downloading these 5 sprof files because I did not have them already downloaded. And then look over in our window, we see now a map of, here's Hawaii, and here's our box that we chose in space. And you can see this is because we're telling it to show the trajectories from the floats, it's showing all of them. But now let's say we just want to show particular profiles, so just the profiles in that box. Then when we call show trajectories here, we're going to tell it to use specific profiles. That makes sense. So if I run this, you'll see the difference, that basically it plots now just the profiles within this box, and also select windowed in time as well. Okay. Now, let's say out of all these profiles, for whatever reason, we're really interested in what's happening in September near Hawaii. We have a cruise that was measuring stuff there, and we want to see what does the BGC Argo data in this region in September look like. So the next block of code, so before we do that, we're going to just show the profiles from all the floats. So all 5 floats, we're going to plot only QC good or probably good data from all of these floats. So we're going to give it the profile IDs to show profiles. We're going to tell it to plot salinity and oxygen. And then this per float flag is an optional argument that lets you either plot individual figures for each float if it's set to 1, or if you set it to 0, it just puts all the profiles on one plot regardless of which float they came from. Okay, so here it's going to make 2 plots, one for salinity and one for oxygen, and they're going to plot all the profiles from this region, for all months basically. So here's the salinity, and you can see some of the floats stopped around 1600, some of them sampled down to 2000 meters, and then the oxygen profiles. Also, you can see that there's some differences in sampling between the different groups of floats, so it causes the mean to behave a little funny in these regions. So you just want to be aware of that. Okay, so now we can just say we're interested in just profiles from September. So how could we extract which profiles from this set of profiles? So we have this Hawaii profiles, which is our list of the particular profiles in our box, and we want to find which one of those were taken in September. Well, we can, this is shown in this next block of code. So we query the sprof structure, the date variable within the sprof struct, and by passing that to datevec, we can extract the month. So this is now a list of all the months for each profile. And then we say plot or select only the profiles from our group that have the month equal to 9 for September. And so now this gives us a list of the indices of the profiles in this box in September. And now we can plot them using this command. Again, we'll plot salinity and oxygen. We'll plot all the floats together on one plot, and we'll plot a marker at each observation. We can also pass this along to tell it to plot, add September to the title, which is really nice. And then use, of course, QC 1 and 2. So when we do that, we get 2 new plots, one for salinity. So this is all of the salinity profiles in that box from September. And then in the next plot, we see the oxygen data also for September. And again, you see there's probably 2 different, group, or maybe these in this box, you're sort of sampling maybe 2 different regimes. Okay. Now we can also look at some sections for one of these floats. So we can just sort of say the 5th float, the last one on our list. We'll pick that one and we want to plot some sections. We're going to plot sections of pH and oxygen, and we'll tell it to calculate the mixed layer depth using a temperature criterion. And also, in this case, we're going to plot the unadjusted data. And then in the next case, we'll plot the adjusted data, again, just to kind of highlight the differences that you might see. So if we plot the first of the section plots, there'll be 2 plots, one for pH and one for oxygen. Okay, so pH, and again, it lets you know that these are the raw values, so use with caution. But you get a nice section where you can see the isobicnals have been overlaid, the mixed layer depth calculated with the temperature criterion is overlaid as well. And then if I run the next block of code, you'll see what happens when we just plot the unadjusted data, the adjusted data. And in this case, there's not, there's not a big, this is sort of maybe a more typical case where the adjusted data versus the unadjusted data, there's maybe not these huge changes like we saw with that first example, which we really picked a float to highlight sort of a really egregious example. But this is more typical of a float where, if you kind of flip between the raw values for pH and the adjusted values, you'll see that, there are important changes that are, we're thinking about using these data for science applications. There's really, you want to use the adjusted data, so there's important differences, but they're not these, necessarily drastic changes that we saw in the first case. Okay, I'll stop there. Are there questions or comments or anything that people would like to add?
Thank you. This is great.
Great. Thanks, Ken.
Yeah, really nice. Thanks, Allison.
Yeah, well, really, I have to give all the credit to Hartmut and John for writing the code. And we have a few updates, if people are using this and they see that things, things could be improved, or they they find a bug or something, we are, kind of would be happy to get the information via GitHub, like put an issue on GitHub, or you can also just email us or any other contact way. And we want to have also, thought of a few different features to add here. Yeah, I see there's some.
I have a question.
Yeah.
Oh, sorry, was it? Okay. I was wondering if there was a really simple way to just extract the mean and like the standard deviation of a certain set of profiles. You mean to like it, not just plot it, but to like then save that
as a variable in your workspace?
Yes.
That is a good question, and I'm sure it would be an easy to adjust the code to do that. I'm not sure if maybe Hartmut can say if there's a
Yeah, it's not coded to do it, but it's a few lines of extra code, and you can do it yourself.
yeah. So a lot of
If you look in plot profile, it's calculated, and you would just have to return it.
yeah.
So it's not even a line of code. It's just you just add it to the at the top, very top. You just make it in a return value.
Okay, great. Yeah, thank you.
Yeah, so in this auxiliary directory is where a lot of the, if you want to dig down into the different scripts and things, you'll find them in here. And here you can see how it calculates the mean over multiple floats versus the mean over one float. So, I mean, it's right, as Hartmut's pointing out, you can easily get it from here. Yeah, thanks for that question. Any, like, what else? We have a few minutes if people want to take a break. I know we had a little bit of delay, but I'm happy to stick around if there's questions, or feel free to, step away if you need a break. Are there things that people see that either that you would like to do with BGC Argo data that we didn't cover, or that you regularly do yourself that are really useful?
There is just a discussion whether we should go back on schedule. We're, technically, I guess, overtime now. Is that right? Yeah.
Well, I think the break was at 11:45. So yes, we're overtime.
Yeah.
That's why anybody who I just said, like, I'd stick around if people wanted to.
Yeah. No, I mean, if people don't have questions, so this is great. So Allison, Hartmut, John, everybody that worked on this this is a great service to the community. I think we can stay on to, I'm multitasking. There are text messages going back and forth about whether we should reconvene in plenary or not. Looks like we're still not going to reconvene quite yet. So we can keep asking you questions.
Alison, can you hear me?
Mm-hmm.
So in this last plot in figure 9, I see there is some missing data in there or something. Yeah.
Mm-hmm.
So going back to your comment and Yui comment on if we find issues, we need to put those issues in the feature of a GIT hub. In this case, is that an error after the adjustment, or is that something that we should not be concerned about?
I think in this case, like, it's not an error, like a bug or anything like that. It's that I would have to look at the specific reason, but for whatever reason, in the adjustment process, that profile was deemed sort of unsavable or maybe probably bad. So I think it's just a matter of the quality of the data. Like the raw data is still there, and I don't think it was like an error in the plotting or anything. It's more that when we applied the QC flags and only look for good data, that particular profile was marked as being bad.
Maybe Ken, you can go.
Yeah, two quick comments. The pH sensor returns some engineering diagnostic data, and we use that in an automated sense to determine the quality of the pH as well. The sensor could have been working really well, but the diagnostic data could be erroneous. And, So that would lead the automated systems to mark the data bad. So the second point is, you know, if you find data and you think the bad data is good or you think the good data is bad, and there are clear cases of, you know, of that, communicate back to the person listed in the NetCDF file as the principal investigator. And in our group, we call this an informal audit, where the community comes back. You know, we do our own auditing of the data, but other users, if you come back and go, you know, we just don't think that this pH is right, and, you know, we'll take a look, and maybe it is right, maybe it isn't, but we appreciate the input. Yeah.
Yeah, thanks for that question. Oh yeah, and there's Tanya put a link about different DAC managers, so people you can contact too, I believe, about the data quality.
I mean, in particular for BGC, this is still an evolving art. And so all the help we can get and discussion, it's all super valuable to us.
I'll also add too that you know, the DAC managers across the globe we're managing a lot of floats, and we just hired someone onto our team at Mbari that will be starting soon. But so there are things that, you know, slip through the cracks. I've gotten emails from users before that have identified small issues here and there that we can then promptly address and fix and push back to the repository. So yeah, we're always welcome, but I guess I would suggest do a little sleuthing on the front end, you know, maybe comparison of raw versus adjusted to kind of figure out what's going on, or look at things in a multi-parameter context like Yui suggested prior to emailing. But yeah, always welcome to hear from the user.